adding a shape to our repertoire. A shape to the options of things we're finding areas and perimeters of. Yes, great. Moving forward.
I can't wait.
Now, if you have a quadrilateral that has 4 congruent sides, that's what's known as a rhombus. Now, that's not what probably some of you thought about. What do you typically think about when you think about a quadrilateral with 4 congruent sides?
Square.
A square. Now, a square is a rhombus, if you recall from back in chapter 6. A square is a rhombus. A square is also a parallelogram. A square is also a rectangle, which means you can find area of squares a number of different ways. A quadrilateral that has 2 pairs of consecutive congruent sides is known as a kite. So here, I have a rhombus, and I have a kite that we can work with. In order to work with rhombi and kites, we have to know some features about them because sometimes they're not going to give us everything that we would like going into it. So, starting with our rhombus. Not only does it have 4 congruent sides, but its diagonals get broken up into congruent parts as well. Specifically, the 2 parts of the same diagonal are congruent. And that's true of both sets of diagonals within a rhombus. Furthermore, when it comes to a rhombus, the diagonals are perpendicular, meaning they create a right angle. And last but not least, the angles of the original rhombus get divided into congruent parts by the diagonals, making this angle congruent to this angle, which is also congruent to the ones on the opposite side. All 4 of those little angles are congruent. And the same can be said about these 4. This one, congruent to this one, congruent to this one, congruent to this one. And those things at some point or another all get used when finding areas and perimeters of rhombi and kites. Kites is a little bit more there's a word that I was going for there and it's gone. There's fewer things with a kite. Kites' diagonals are also perpendicular, so they do also get that right angle. They only have one diagonal that gets cut into 2 congruent parts, though. And it's the diagonal that separates the pairs of congruent sides. Those are congruent, those are congruent. The diagonal that breaks that kite up like that is the one that gets marked as congruent. Now keep in mind, am I allowed to spin a kite and show it to you this way?
Yes.
Yes. Hence the reason we look for the congruent sides. Congruent sides, the diagonal that breaks the pairs up. We also do get some congruent angles, specifically the 2 right next to one another between the congruent sides. These ones are also congruent, but they're not the same. They're congruent to each other, but not the same as the ones on the other side of the kite, is what to clarify what I mean. So kites have fewer congruencies. Kind of works in our favor. Formula for the area of a kite says area equals 1/2 d sub 1, d sub 2. What is in between the 1/2 and the d sub 1 and the d sub 2? What symbol? Multiplication. D sub 1 stands for diagonal 1. D sub 2 stands for diagonal 2. Now it does not matter which diagonal you call the first one and which diagonal you call the second one. The key thing is a diagonal is the full distance across from one corner to the opposite corner of the rhombus or the kite. They use the same formula. So, question A, what does it ask for? Area. Do you notice it didn't ask for perimeter? Sometimes it won't. Sometimes it will. How do you find the perimeter of a shape? Add up all the sides. The sides I would add are that one, and that one, and that one, and that one. Do I know the length of any of them? No, that's why I didn't ask for the perimeter. Okay. Do you notice this 7 it mentions right here? Can you tell what that is actually trying to show you the measure of?
Height.
Not height.
Diagonal 1.
It's one of the diagonals. We can call it diagonal 1. It's trying to tell you this length. This is this length. Diagonals are hard to put on pictures for their measurements specifically. So, oftentimes they'll do it on the outside. Can you tell what the 10 is trying to tell you the measurement of? The other diagonal. This length is trying to tell you this length. So yes, that is diagonal 2. Is this a kite or a rhombus?
A kite.
It is a kite. I ask this because, not because you need their formulas to be different, but because one of the biggest things you have to do in this chapter is first recognize the shape. That tells you what formulas to use. And the kite formula, we just wrote it down, is this. So, area equals 1/2. And we said what was between the 1/2 and the d sub 1? Multiplication. And I say d sub 1 because that's the technical way you say it. You can call it d1 and d2. I understand what you mean. Sub means subscript. That's what those little numbers are. Okay, 1/2 times 7 times 10. How do I put that in a calculator? 1 divided by 2 times 7 times 10, or 0.5 times 7 times 10. What do we get?
35.
35. What units?
Centimeters. Squared.
Remember, it's an area, so it's centimeters squared. Done. Question 2 gives you the measurements a slightly different way. Have to pay attention to what it's giving you the measurement of. The first measurement it's giving you is WR. There's W, there's R, it's giving you this length. Is that a diagonal?
Yeah.
Diagonal goes all the way across.
Oh, wait, no.
That's part of a diagonal.
That's a rhombus.
Overall, the shape is a rhombus, and that is going to be one of the things that I was going to ask next. Okay? The other measurement it gives us is Vx. V is here, X is here, going all the way across. Is that a diagonal?
Yes.
Yes, that one actually is a full diagonal. So, being a rhombus, that means our formula is still this. We have one diagonal. We can call that d sub 1 if we'd like. We don't have the other diagonal. We have part of a diagonal.
Can't we just, isn't the diagonal, wouldn't it be 12 times 2? 12 squared.
Yes. Not squared. That's a different thing. Nate's pointing out, essentially, if this is part of a diagonal, is this part of the diagonal the same? Yeah. Since this is congruent to this, if I want the length that goes all the way across, this part being 12, this part being 12, I can do 12 plus 12 and get 24 as the other diagonal. I'll call that D2 because I already called the other one D1. Area equals 1/2 times 18 times 24. The thing you have to be careful is just make sure you've got the full measurement. And you type it into a calculator. 216?
Yep.
216 watts.
There was no measure.
There is no units on it, so what do we do?
Just leave it.
Nope. Do you remember what letter stands for unknown units? U. Okay, next page. What shape is problem C on the top of the next page?
Kite.
Yes, on the top of the next page we have kite.
Exactly.
Does it matter if we have a kite versus a rhombus?
Yes.
Yes, in the sense of measurements are not always the same. The formula is the same for finding the area, but the measurements have slightly different relationships. First thing we're given is DM. That goes from here to here. Is that a diagonal? No, it's part of one. Okay, next thing I was given is DG. That's this. Is that a diagonal? Definitely not. That's a side. The next thing I was given was EF. That's this. Is that a diagonal? Also no. Also a side. And the last thing I was given is MG. Is that a diagonal?
No.
It's part of one again. I'm not given a single diagonal. But we have some relations within kites that tell us congruencies. One of the diagonals got cut into two congruent parts. But is it DM congruent to MF or is it EM congruent to MG?
EM congruent to MG.
Yes. This diagonal breaks the kite into congruent sides on the right, congruent sides on the left. The diagonal that breaks that up that way is the one that's congruent. So this and this are the same length. If MG is 24, EM is 24, and therefore to get all the way across, yes, 24 plus 24, or 24 times 2 if you prefer.
Do we have to do Pythagorean theory for to find the other diagonal?
Yes. We weren't there yet, but yes. To get the other diagonal, I want to add up this length and this length, but I don't know that length. And if you don't know things, in this chapter, what shape helps us find things? Not just any triangles, but right triangles. Remember, in kites and rhombi, the diagonals are perpendicular, and all of a sudden we have right triangles. We have 4 right triangles here. One of them will help us. we need to know this length, which means it's not one of those two. It's one of these two. Which one do I know the most information about? The top one, because I know what EF is and I know what this length is. So sometimes you have to pull out that right triangle. Now you don't have to draw it separately, but for some people it helps seeing what's going on. So I'm going to do that. Just going to pull that down there. I'm going to label what I know about that right triangle. What is the length of EM? It's got triple tick marks on it, which means it's the same as MG, and MG was 24. MF is what I'm missing. I'm going to call it X. EF was 30. Is it Pythagorean theorem or trig that I need? How do you know it's Pythagorean theorem and not trig? Because it's three sides that we're working with. When you're working with three sides, one of which you're looking to find, that's Pythagorean theorem. Which side's the hypotenuse? 30. So, x squared plus 24 squared equals 30 squared. Start by squaring some things. X squared stays x squared. 24 squared is 576. Anyone? Can we verify that?
Yeah.
Sweet, thank you. 30 squared is 900. After you square things, not square root, square, you're putting the power of 2 on them. The next thing you do is subtract the 576. X squared is equal to 324. Far too many people on the quizzes, not as many, but some people stopped Pythagorean theorem right there. They called that X. What do you do to get X? Don't change your X squareds into X's until after you've taken the square root. Square root of 324 is a number.
18.
Oh, it's 18? It's just a nice number? Ooh, that's nice of them. And that was this. So this length is now 18. How'd you get 28?
10 plus 18.
Yes. DM was 10. MF was 18. So yes, all the way across is now 28. The 48 and the 28 are our diagonals. One half times D1 times D2. Nate says it's 672. Can we verify that? Because I don't know the answers off the top of my head.
Yeah, it is 672.
Beautiful. I figured it was. We don't know the units, so it's units squared. One more like this, and then we're going to talk about some working backwards problems. Can I shift? Here, I'll just zoom out instead of fully shift. I am given the measurement CQ. I am given the measurement QE. I am given the measurement DQ. Are any of those full diagonals? No. But I got two parts of the same diagonal, which means I can do what to find the full diagonal? Add them. It was 14 square roots of 3 plus 28. Now that doesn't look particularly friendly, does it? But the calculator knows what to do on it. You type in 14, and then you type a square root, 3, and you close your square root. You do not put a symbol in between those. If you do, what symbol would invisibly be hiding between them? Times, not adding. Times. But otherwise, we generally just put them up next to one another, plus 28. 52.25. I'm going to call that diagonal 1.
Where did we get the never mind. I thought that was 18. I thought that 28 was 18%.
Yeah. Valid question at that point. How can we get the other diagonal?
Just add 13 plus 13.
How do you know it's 13 and 13?
Because that one's congruent.
Because that's the one that gets broken into two congruent parts. Because congruent sides, the diagonal that breaks that kite up is that one. I write down the formula every single time. If you haven't noticed that, it helps me to make sure I use the right one. But then I just plug in. That's what I got as well, unit squared. Okay, the last two problems are the working backwards problems. The first one gives you the picture. Says, find the missing dimension round to the nearest hundredth if necessary. What shape? Because that's always how you need to start these questions, is what shape is it? This one's a kite. Now it doesn't have the markings for a kite, but can you kind of tell it looks like a kite? I am not trying to trick you. If it looks like a kite, it's a kite. If it looks like a rhombus, it's a rhombus. What information am I giving you about this kite?
The diameters.
They're not diameters.
Diagonals.
We're given measurements on diagonals, and we're also given what other piece of information?
Area.
The area. That tells you what formula you're going to have to use, is what information I give you. I gave you area, so you use an area formula. Area formula is still this for a kite. And I plug in what I know. There are 3 variables in this equation. I can plug in something for each of them. What goes into A? 92. Don't lose the 1/2 as you do this. What goes into D1?
22.
Either 22 or
X.
X, doesn't matter which one. If I put 22 into that one, X goes into the other one. And now you solve. If I want to solve an equation like this, where do you think I should start?
Minus 1/2 both sides. So 1/2.
Okay? No. And no. First off, it is multiplication, so we can't subtract. That's not going to do us any good. And if you half both sides, you are multiplying by a half. Does multiplying by a half undo multiplying by a half?
Divide.
Divide by a half.
Did I not say that?
No.
Okay.
You said multiply.
Now, if you're going to straight up divide by 1/2, then that 1/2 better be in parentheses. Technically, your calculator will not understand it dividing by a half any other way, because dividing by a fraction, we typically multiply by its reciprocal. The reciprocal would have been 2.
Oh, yeah.
So, if you do 92 divided by 1/2 without the parentheses, you'll get 46, which is not correct. 92 divided by 1/2, oops, it's 184.
Mine's fancy. I don't need to do that.
I'm fancy.
Yeah.
Not everyone gets fancy.
How does it become a bigger number if you divide by a half?
Because to divide by a half is like taking every single 92 and dividing it into 2 parts and asking how many parts there are. If you take one thing and divide it in 2, you now have 2 parts. Now, how do we get x alone?
Subtract.
Try again. Divide by 22. 184 divide 22. 8.36. And this is a length, therefore its unit is inches. The last problem is the one that's going to cause the most issues, because it's purely words. And it's got something a little bit different in what it looks like when we solve. First off, it tells you the shape. Kite. A kite has a diagonal that is 4 times as long as the other diagonal. If the area of the kite is 40.5 square meters, what is the length of each diagonal? I told you area, I told you kite. That tells you which formula. Just like before, we're going to plug in what I know, or what we know, but we're going to have a problem. We weren't given anything regarding either diagonal. So we're going to have to talk about those. We were given some information, but we weren't like, it wasn't like this one where we were told one diagonal is 22. What were we told about the diagonals? One of them is 4 times as long as the other, but does it tell you what either of them is? No, which means I have unknowns for both of them. Now, I don't want to use 2 different variables. You can't solve one equation with 2 variables. But here's what you can do. Start with one of the diagonals. Call it a variable. I like x. And then for the other diagonal, pay attention to what it said. How did it say the diagonals were related? So it said to take 4 times as long, which means you take the first diagonal and do 4 times it. 4 times x or 4x. I now have something I can plug into each of the diagonals. Diagonal 1 is an x, diagonal 2 is a 4x.
Combine like terms.
They're not like terms because we're not like adding and subtracting, but you got the right idea. Put that stuff together. All of this is being multiplied. Does it matter the order in which you multiply things?
Yes.
Is 5 times 2 the same thing as the 2 times 5? Yes, order does not matter in multiplication, so you can multiply in any order. Which things multiply most easily? The 1/2 times the x, the 1/2 times the 4, or the 1/2 times the other x? Which would you rather multiply? A number by an x or a number by a number? Generally a number by a number. 1/2 times 4 is 2. What is x times x? X squared. That's what that simplifies to. I want to solve for x. Start by dividing by 2. You get 20.25 equals x squared. To get rid of the squared, you take the square root. Square root of 20.25 is 4.5. What did the question ask?
Find both sides.
The length of each diagonal. Find both diagonals. Diagonal 1 is 4.5 meters. How do you find diagonal 2? Multiply that by 4 because it's 4x. 18? Meters. Diagonals are 4.5 meters and 18 meters. Doesn't matter which one's D1, which one's D2, those are just the lengths of them. Kites are pretty straightforward. You just got to make sure you have the right lengths. These word problem ones get a little trickier. That was 11.3 day 1. Today is the 16th. Our homework is due on Tuesday, the 22nd, because that's 2 school days from now. Should you be waiting to do it? Remember, 11.2 worksheet is due today.